Future Print Virtual Summit. This next session is really eye-opening for me, and I've learned a lot about this technology in the last, and hope to learn some more. Interesting enabler, I think the key word is here, for some new possibilities, which is perfect, I think, given the situation of the markets and the world is right now. So I'd like to introduce Anthony Carignano, who is the Director of Marketing with ACTEGA North America Technologies. The title of the session is Direct to Object, Introducing ACTEGA Decorating, and in brackets we have a crystal there as well. So I'm sure Anthony is going to illuminate us now for the next 30 minutes. So over to you, Anthony.
Thank you very much, Marcus. So I'm Anthony Carignano. A lot of folks call me Tony. I've been with ACTEGA North America Technologies now for a little over 2.5 years. I have about 10 years of background in the photopolymer industry. I originally started my journey in photopolymer chemistry, as well as the application side of it, with a company called Allnex North America, which is a manufacturer of photopolymer resins. Was there for about 4 years. After that, I worked for a company called E-beam Technologies, which is a manufacturer of low energy electron beams, which are also used to cure and cross-link photopolymer chemistry. And then after that, I started my my journey here with ACTEGA. So I'm a part of the new technology incubator, which operates within ACTEGA Global. So we were really set up to take new concepts, new chemistries, new applications, and more or less bring them along so that they can be very easily and very flexibly launched into the market. So with this presentation, the first thing I'm going to do is spend about 3 or 4 slides on briefly introducing ACTEGA, so it gives you somewhat of a context for what I'm talking about and the funding that we're getting for this. And then I'm going to jump directly into ACTEGA decorating technology, crystal decorating technology. I'm going to talk about basically the print transfer concept itself. Then I'm going to talk about the value proposition for this technology versus pressure sensitive labels. So I'm going to mention PSL several times in the presentation. I'm then going to compare and contrast it briefly with screen printing. And then I'm going to mention DTS, or direct to shape printing, a few times also in the presentation. And then I'm going to talk about the startup process and the workflow for the technology, because I think that's important to know also about how we're actually taking this to market. You know, one thing is basically to create a product, and then another thing really is to how do you find the right market niches and the needs in the market for this, and how do you speak the right language so that your customers or your potential customers realize what the value is for the technology. I frequently think about the iPhone. When it first came out, a lot of folks didn't know that they needed an iPhone until it was explained to them the technology, how the technology works, and how it would make their lives better. So, and you know, several senses, that's kind of like what we're going through now with ACTEGA decorating, is explaining why the market needs this and how this would improve basically several dimensions within a brand owner's perspective. Then I'm going to be talking about the media briefly, and then the hardware, and then we're going to be wrapping it up with just a few final thoughts on process flow, and then I'm going to summarize, and then we'll end this. So I work for ACTEGA North America, which is one of 4 divisions within Altana. The other divisions are BIC Chemie. So anybody who's ever been in the formulating space would know BIC Chemie, because they manufacture a lot of specialty additives, rheological modifiers, defoamers, things of that nature. Another sister company is called Eckhart Pigments. They manufacture metallic pigments. And then we have another company called Atlantis, which manufactures clear coatings for wire and cable, a lot of automotive applications within that group. So within ACTEGA itself, ACTEGA has approximately $350 million on a per annum basis in total sales. These are 2018 numbers, but more or less sales have been within a 5% delta of that in 2020. Something unique about our organization is that we invest about 10% of our annual sales in R&D on a per annum basis. So we are heavily driven to innovation and getting new products out into the market. We have basically a global footprint, and we have about 1,150 folks, experts around the world that are supporting our growth. This briefly will give you, this is basically an overview of where we're located: North, South America, Europe, in Europe as far as footprint, as well as in Asia Pacific. So now I'm going to talk about ACTEGA decorating, and the concept itself is a print and transfer concept as opposed to a direct-to-shape printing concept. We've called this technology for the past 2 years Project Crystal. So you'll notice that there are a couple of articles out there with me referring to this as Product Crystal. We've decided we are at the moment going through a rebranding process for this, and that new product name will be launched probably within the next 2 to 3 weeks. So this is a fully patented process that we've developed. The chemistry as well as the hardware know-how for this process have been developed internally at ACTEGA at our R&D center located in East Providence, Rhode Island. And so for the container decorators that are out there in the market that would benefit from this product, basically it's providing really a unique way of printing and then transferring a very high quality graphic over to containers. All of the chemistry that we've developed is specific to the process, as well as the carrier films that we've developed for this, the release agents, as well as the hardware. So, you know, I frequently say that, and folks have asked me this, if we take your hardware and we want to apply our conventional pressure sensitive labels with it, it won't work because of the unique way that we've designed this. And we actually apply our decorations sticky side out as opposed to how a conventional pressure sensitive label is applied with a face stock side out. So why have we developed this technology, and what's the value benefit for it? On a very high level, you know, brands today, they're constantly reinventing. I would say that the consumer product packaging in the narrow web space are probably some of the most innovative, is probably one of the most innovative spaces out there in the market today, because literally you have to innovate or you're going to sink. Your competitors are constantly innovating and coming up with something new. So in that vein, they're always looking for something that's different, and I think that's what we bring to the table, is something that's unique. What also we bring to the table is a new way of looking at narrow web printing as well as container decorating, which significantly reduces the amount of media that's used, or basically raw materials that are used in creating a decoration that is transferred over to a narrow web or to a container, sorry. And then I put plastics in parenthesis, but basically there's a big need in general for container recyclability and led by plastics. In the United States, if you compare the United States to Europe, in the United States, you know, I think that they recycle on a per annum basis, at least last year, about 20 to 25% of all the PET that's used in consumer product containers. That basic number is much higher in Europe than in the United States. There's a big need for improvements in plastic recycling. There's a big need, at least in North America, for improvements in glass recycling for that matter. And so we believe that we bring value to that as well, in allowing you to more easily recycle your containers with this technology. So what is crystal decorating? In a nutshell, basically, it's a new approach to decorating consumer products, rigid containers, using a very minimalist printing process and an application process. Our process basically is a full Pantone process, and as I'll show here in a couple of slides, you know, the process today is printed in a 100% flexographic approach. What we're moving into here pretty soon is a hybrid digital flexographic approach with this, and hopefully within the next year to 2 years, we'll be able to transfer that whole entire approach over to 100% digital technology, which is based on some of the new developments in head technology that allow you now to print coatings where you couldn't before because of the high viscosity of the coatings. So, you know, once again, what is ACTEGA decorating, crystal decorating? It really is. It's a hybrid. It's a basically it looks like a no-look pressure-sensitive label, but it does have the feel of a director-shape printing technology. One example of this would be what we've done with this container here, where you literally can fill the decoration as you rub your finger over it because of the high build that we've applied to the container with it. So the process itself starts off with using a BOPP film that has a release layer on it. So that's a biaxially oriented polypropylene film. What we're doing first is applying we refer to it as the L3 layer, or the liquid layer, which basically in common vernacular would be referred to as an overprint varnish. But basically our coating is above and beyond that. It has a very robust profile to it that allows for high scratch resistance, high coating resistance, high solvent resistance as well. So we're laying this layer down first. This layer is laid down either as a flood coating or as a spot coating onto the surface. And then after that, we're applying our process colors over top of the L3 layer. And then in the final portion of the process, we're laying down a spot white, and then we're laying down basically a UV pressure sensitive adhesive. So literally it's building a pressure sensitive label in reverse without the need for die cutting, as I've just mentioned here. So if you take a look at the way that we build a crystal or an ACTEGA decorating design versus a conventional laminate, face stock laminate pressure sensitive label, we're not basically using a face stock. So that in itself represents up front about a 30 to 40% savings in material that's typically used in creating a label design. On top of that, we're really judiciously using the amount of adhesive that's required because we're spot applying the adhesive on the back side of the decoration stock. And then we're also minimizing several other things that are typically used in creating a label stock. That there's no over laminate that we use with this technology because that's basically being replaced with the L3 layer. The design area that we're taking up with this has been minimized by about 80%. And then the matrix also that we're using with this has drastically been reduced as well. Yes, BOPP still is a plastic film. Yes, we realize that plastic films at the moment are very hard to recycle out there in the market. Yes, we are also looking at other ways of carrying the decoration over to the container by using either post-consumer recycled films or hopefully aspirationally in the future compostable films, which are totally doable. They're used today in the flexible packaging industry. So that the converter, basically once they print the decoration onto the carrier film and it then goes out to the container decoration house, that container decoration house, if they live someplace where there's an entity that accepts compostable films after application of the decoration, they can ship those films to a composter, an industrial composter. And so basically you're drastically reducing the footprint that you're actually making with regard to putting stuff in landfill. So let's talk now about how would you compare ACTEGA decorating technology versus UV screen printing. So for those of you that don't know that much about UV screen printing, it's a process which enables the ability to apply graphics, logos, and designs directly onto container surfaces. It can be applied to glass, plastics, as well as metallics, and it basically uses dedicated color stations. It enables a lot of flexibility with regard to how you present your brand image, and also giving you the ability to make even embellishments above and beyond simply the print. You can also add metallics as well as special effects onto the surface of a container by using screen printing. So our process, basically, it allows you to, as well, print and apply very high opacity, but in this case, full Pantone colors with a no-look format, which is quite difficult to do with screen printing. You're also getting much better color consistency as well as control over color matching in-house when you use this technology over screen printing, because literally all of our designs are printed in advance and using an inline flexographic process. There's no screens with this process, and there's no color or print registration, which is required with the process because it's all done with screens. I'm sorry, it's all done basically with a flexographic plate, which is then transferring the image over to the carrier film. And it also significantly reduces the amount of cleanup that you typically would require in a print job as well. So there's no post-curing with this, there's no baking, there's no hardening, because that's literally all done at the printer before it ships out to the decoration house. So it really also provides the decoration house or the entity, be it a brand owner as well, or a co-packer that's applying the decorations onto the container. It helps you to optimize the amount of footprint that you're using in your own plant. It also gives you the ability, which is quite unique, to literally come up with or to develop a 360 wrap design, which is very difficult to do with UV screen printing. Typically with UV screen printing, if you're trying to go for a 360 wrap, there's a lot of smudging and there's a lot of potential for blemishing if you do that, because literally you're rolling the bottles past pads as you're applying design onto them. So it's really hard to get a 360 wrap with conventional screen printing, whereas we can do that automatically with our process. With our process also, you can apply a matte finish or also holographics to the surface. We do that by using an ablated film, which transfers an image onto the L3 layer, which allows you to come up with some really unique looks with the way that the decoration finalizes itself. And with this technology, you also have the ability to do ultra short variable data runs if you're running the hybrid process as opposed to the flexo process. And then once again, it also increases the reusability potential of glass as well as plastic containers. So now let's talk about direct-to-shape printing. So direct-to-shape printing is growing quite quickly out in the market. It's a way to efficiently use piezo drop-on-demand printing in a full-color image process where you're printing directly onto containers. However, this process does require, one of the caveats is, you need a surface that's very, very homogeneous in order to get a full fidelity image to be created onto the surface. So with direct-to-shape printing, you do require primer coating to go down to actually hinge the ink onto the surface of the container. And in most cases, when you're direct-to-shape printing, to improve on scratch and mar resistance, you have to put an overprint varnish down as well. So there are several steps in that process. Direct-to-shape printing, the printers, they come in a variety of sizes and shapes. There are smaller ones that are out there on the market that typically can process between 3 and 4 containers on a per minute basis. And then you have much larger ones, like from Velox, that can basically output literally hundreds of containers on a per hour basis, all depending on basically the cost of the equipment. Our process, it alleviates the need for print receptive primers. It also alleviates the need for top coats because it's all built into the design of the ACTEGA decorating sandwich, if you will. It also provides the ability to incorporate, as I just mentioned, mattes as what finishes, as well as holographics, which you can't really do with direct-to-shape printing. And it also encapsulates the layers onto the surface of the container in a way that when you do go to recycle the container, it'll exfoliate, once again, the decoration off of the container so you're not fouling the plastic. And it gives the plastic the ability to be recycled very quickly and very efficiently without creating cause or concern in the recycling process. So our decorating technology, it also gives the ability with the way that it conformally lays on the surface of glass specifically. It gives a way of basically camouflaging certain defects within glass. We've also noticed that it can basically cover up defects or any types of ridges or seams that you see in plastic as well. So it basically conformally lays on the surface and it looks like it actually becomes a sublime part of the surface. With our technology, we have the ability to dial in or dial out the molecular weight of the resin systems that we're using in the L3 layer. And we can also basically formulate this technology so it complies with indirect food contact regulations or any type of skin contact regulations that the brand owner might have. That's really hard to do with direct-to-shape printing, because with direct-to-shape printing, you're using monomer-rich fluid systems that have a high propensity for migration. So let's talk about the performance attributes of the technology. So solvent resistance, we typically do a lot of in-house testing using methyl ethyl ketone or MEK, double rub testing. And we know that with our technology, we get well above 50 double rubs with MEK solvents when we test them. Scratch resistance is extremely high as well. With the technology, we do multiple scratch tests. We actually do a lot of abrasion tests too, especially when we're looking at how our decorations will behave when they're transported. And so that's really important to know because typically containers will sit basically packed on a crate together and they'll rub up against each other as they're being transported inside of a truck over several hundred miles. So you would really want to make sure that the L3 layer of our chemistry will not abrade or will not scuff or will not start to fluoresce if you scratch it a lot. And so that's what we've developed and formulated into the chemistry for it to be robust in that respect. I've mentioned already recyclability several times. What I'm talking about in this slide is typically what happens in a recycling process for primary and secondary labels. A lot of folks have never been into a recycling center, a municipal recycling center. Municipal recycling centers, they use a lot of near-infrared sortation systems that try to identify the species of plastic by bouncing light through or off of the surface of the plastic. When you're using shrink sleeves or certain other types of labeling devices on the surface, it's hard to determine what type of plastic needs to be recycled. With our technology, because it is a no-look type of technology, it makes the plastic very easily detectable to the near-infrared sortation systems. And as I also mentioned, with our technology, once it enters into the recycling bath, it very easily separates from the plastic. And so it allows the plastic to be very easily recycled. It also allows for much higher, they refer to them as bale yields of plastic, as opposed to also having parts and bits of labels shipped off with plastics to a converter. We've also run our technology on PET, and we work with the Association for Post-Consumer Plastic Recyclers. We've run our technology through what they refer to as their PET S04 thermoplastic label testing. And in a 5-tier full build, we've come out successfully demonstrating that our decorations will fully exfoliate off of the PET plastic and allow that plastic once again to be recycled very easily. So now let's jump into hardware and the hardware that we've designed for this technology. So if you were to walk into our labs in East Providence, Rhode Island, literally on the right-hand side of the building, we have all of our chemistry folks that are formulating and doing application testing with the decorations that we're developing. And on the left-hand side of the building, we have our engineering team. So our engineering team is responsible for developing the equipment that's needed in order to apply the chemistry that we have going on the right-hand side of the building. So we have developed our own inline decoration applicator for this technology. It's on the surface, it's a very simplistic, a very straightforward piece of equipment. However, its glory basically is the ability to take very, very thin films and being able to transfer the decorations that are no more in certain cases than about 25 or 30 microns off of that 1 to 2 mil BOP film and transferring it directly and very efficiently over to a container that's literally flying past it on a conveyor system. The applicator that we've designed, it's simple, straightforward. It runs off of a single 110 volt, 15 amp outlet. It's designed for controlling containers in a very high throughput fashion for high transfer accuracy. It reduces the electromechanical complexity for maintenance as well as the integration of the system. So the system that we've designed could literally be parked on an inline filling system if you wanted it there as well. And it provides a very simple wet path for decorating the containers. Literally what you're doing is taking a roll of printed media and putting it on the spindles, lining it up on our application pads, and then turning the system on, and then dialing in basically what you want it to run and how many containers at what line speed, and it'll do that for you. The dimensions of the system, it's not a very large application system. In US feet, it's approximately 6 feet in total length by about 5 feet in depth. And it's about 60 inches or about 5 feet high at its highest point. This system at the moment, it can address diameter containers up to 6 inches or approximately 15 centimeters in total diameter. I'm sorry, yeah, this is the diameter. The height, it can address also containers as high as 8 inches, which is fully within the realm of a 706 or 50 milliliter wine, a glass wine bottle. And we also ship this with, I think it's at least 5 of our application pads that range in size from 3 all the way up to 15 inches. The application pads, basically, the size of the pad is in tandem with the size of the container decoration that needs to be applied over to the container decoration or the container. This is a close-up of the application zone of the inline decoration applicator, and I'm going to run briefly here the video footage of this, which shows you it transferring decorations over to glass containers, jars. Okay. So safety is really important for us at ACTEGA. We've had several safety reviews with the equipment. It complies with NFPA 79. There are e-stops, not only on the control panel of the system, but also in the adjustment stage application belt area. And then once again, the way that we've designed the system, it also has a plug-in on the side of the control panel so that you can add additional e-stop relays to that if you want to integrate the system into an inline process. The system also requires, depending on the container type that you're applying the decorations to, at the moment, it requires that there's sort of flame treating or surface treating before the container has the decoration applied to it. And then here quickly is an example of glass containers being flame treated and then them being transferred over to the applicator where they get their decoration applied to them. We are in a process of formulating a pressure sensitive that will not require, hopefully, flame treating in the near future, which will negate the need for a flame treatment system. Okay, let's talk about the business model that we've developed for this. So our plan is to more or less find homes for about 25 of the inline decoration applicators in North America as well as in Europe in 2021. So for that, we are in the process of reaching out to several OEMs to find if there is interest in having them build these systems for us. So we would hand basically the designs as well as license that capability out to them so that we can further ramp up this technology on the hardware side out into the market. On the media side, in 2021, we'll also be working with several printers as well as converters in the marketplace. So the process would be, if we do receive artwork from a brand or from a decoration house, we would then basically make modifications to the artwork so that it can be printed in an ACTEGA decorating or crystal format. We would then basically send the artwork after it's been modified out to the printer or the converter, and they would be doing the printing, the converting locally, and then basically supplying the decoration house or the brand locally the media to put onto the applicator that we've parked at their location, as opposed to us shipping that media all the way from Providence, Rhode Island to someplace like California or London or what have you. And then there's the brands and the packaging sites. So we also, as I've just mentioned, our intent also is to ship these application decorators out to these sites in 2021, so that literally we have them already sitting out there. So if there is a need for our decorating technology, it significantly reduces the turnaround time to get a container decorated. So we're also looking not only at large brands, but we're really focusing on startups as well as smaller brands with this technology, because we believe that the technology, especially with e-commerce, allows for, it basically becomes an equalizer for smaller brands to be able to react and come up with unique, innovative designs, such as, you know, the same way that a much larger brand would be able to out in the marketplace. So what would, you know, the initial startup look like with this technology? We would basically, once we've met the brand owner or the decoration house, we would ship out to them the Inline decoration applicator. We would work on the artwork initially with them. We would then ship them the artwork, or basically, I'm sorry, at least an idea in Adobe AI format of what the artwork would look like. They would either thumbs up or thumbs down the artwork, then hopefully provide us with the PO. Then we would get to work with having the artwork printed. We would be doing further QC internally with the artwork, actually applying the artwork to containers, making sure that it presents the right way. If we then get further, you know, approval from the brand or the decoration house on the artwork at that point, we would ship them the printed roll. They would run the design on the applicator that we have at their location, and then basically they would fulfill their order. After the first time of doing this, it becomes a lot simpler after that, and it becomes basically a continuous loop of receiving the artwork, approving the artwork, applying the artwork to containers, quality controlling up front, and then basically shipping for them at least the decorated containers off to their brand. So for my presentation, the summary really is that ACTEGA decorating, it is a patented technology which uses UV chemistry and application hardware know-how to decorate rigid container products. ACTEGA decorating is a 100% based off of ACTEGA formulation and hardware know-how, as I just mentioned. All artwork, surface chemistry, carrier films, the labeling equipment use our know-how and technology that's been pre-approved. So if you were to take and try to take our chemistry and apply it using somebody else's labeling device, it's not really going to work. And we're really ready at this point to start collaborating with brands as well as decoration houses out in the market. We're ready to talk to you about how we can make that happen with you. So with that, thank you very much for your time today, and that's my presentation.
Thank you, Anthony. That's excellent. It's very exciting possibilities you're providing the market there, and at a time where perhaps short run in particular, as you mentioned, is both of interest to some of the smaller organizations that are, you mentioned to me before, a little bit about sort of direct to shape beverages. Is that a kind of a potential key market that you see in the future?
Yeah, absolutely. I mean, if you take a look at our technology and the cost of our technology and in placing the technology in the market versus applying direct to shape, direct to shape technology has a lot of upfront costs associated with it and capital equipment. If you take a look on the regulatory side with direct to shape printing technology, you're using high monomer content inks. My concern with that technology is the ink fully cured when it's applied to the container, and are you getting any residual chemistry coming off the container? Is the container fully cured? Whereas with our technology, we have a way of making sure that the chemistry is fully encapsulated and does not migrate. We also have ways of minimizing the potential for concern with regard to the ingredients that are used and the technology once it's applied to the container. So we think there's a lot of benefits to using our technology from both a cost perspective as well as a regulatory perspective, and then also a recyclability perspective versus direct to shape printing. that we bring to the table.
And if somebody wants to contact you via emails, or anthony.carignano@altana.com, is that correct?
That's correct. Yep.
Yeah, yeah. Well, thanks so much. It's really, really exciting, interesting technology. I wish you all the very best with that. And people want to get in contact with you. Here is the information. Anthony also has a profile on the website with a link to his LinkedIn profile as well. And we hope this turns into some interesting further conversations, and best of luck with that.